May 2015, paper 2, number 3. We're going to start this on a separate piece of paper in our answer booklet. The cumulative frequency graph shows the speed of 120 vehicles passing a hospital gate. So remember, think about your cumulative frequency graph as they took all 120 cars and lined them up in a row from the slowest car all the way to the fastest car. And they numbered them with what their speed is. So car number 1 might be going 0, or I don't know where he's going, but each car is going higher speed. So part A says estimate the minimum possible speed of one of these vehicles passing the hospital gate. Well, what's the lowest speed? Well, when we get to car number 1, he's already going pretty fast. So a minimum, let's see, 0 cars passing, we're at 10 kilometers per hour, which is really what this says. So this is problem number 3. Part A would be 10, and you can copy it just like they did, kilometers hour to the -1, or I like to write it 10 kilometers per hour. They'll take either one. Part B, find the median speed of the vehicle. Median, middle. Okay, 120 cars means the 60th car is the middle car. So I'm going to take the 60th car and come across, and let me find out how fast he was going. So if I go back down my grid, I can tell that car's speed. So this is the car numbered 60, and he's the middle car of all 120 cars. So that's going to be 36. So this would be 36 kilometers per hour. That's the median speed. Part C says write down the 75th percentile. All right, 75th percentile. Well, okay, that's halfway, so that's 50th percentile. So halfway to the end would be 75th percentile, or Q3. So if I go down from there, actually between those 2 lines. Looks like it's between those 2 lines to me, so I would come all the way down, and that would be between 41 and 42. So I'd probably say 41 and a half. Okay, part D. Calculate the interquartile range. Okay, interquartile range would be Q3 minus Q1. Okay, so we already had that one, which is 41.5. So now I need Q1, or this beginning quartile. Oh, it's between again. Okay, it's between 32 and 33. So I'm going to say 32.5. And that would be 41.5 minus 32.5 would be 9. The next question. The speed limit past the hospital gate is 50. Find the number of vehicles that exceed the speed limit. Okay, so we have to work backwards. 50 is the speed limit. 50. Alright, so let me find the car that's first going 50. This car right here is going 50 kilometers. And that car is labeled 110. So from 110 to 120, so let's see, that's E. Let's see, 120 minus 110 is 10 cars. Now, we have a table, a frequency table. Number of cars going between 0 and 10 is 0. Let's see. Yep. Number of cars going between 10 and 20. So between 10 and 20, we get up to here, which is, sorry, up to here, there's 20. So that, oh, we're counting by 2, so that's 4? 4 cars? Those first 4 cars are in there. And they actually count up the other ones. So now I just need to find out how many cars were between 50 miles an hour and 60 miles an hour. So between, 50. And this would be the fastest car. He's going 60. I said miles per hour, it's kilometers. So how many cars were in that group? That was 10. It's kind of nice that they filled in the rest of the table for us. So this is the frequency for each of these groups. Then it says to write down, oh, I forgot to write that answer down, didn't I? I wrote it on my paper here, but they're not going to grade that. So F, we're supposed to label what P was and what Q was. G, write down the modal class. Well, mode means it occurs the most. So, occurs the most. This is 64 cars. We're going between 30 and 40. And I want to write down exactly the way they wrote it here. So part 2, write down the mid-interval value for this class. Mid-interval would be midway, so that'd be 35. Use your graphing display calculator to calculate an estimate of the mean and the standard deviation. This is where people always make a mistake. And they try to lead you into it by asking you to find a mid-interval value. In the calculator, we're going to be putting in these values, but we can't put in a range. We have to use an average for each of those. And this is going to go in my L1. So in my L1, I'll put an average for each of these groups. So that would be 5, 15, 25, 35, 45, and 55. The speed is my variable. These are my frequencies. Now I could put 5 no times. I could put 15 4 times, and so forth. Or you can put all of these in L2 and just remember that these are our frequencies. They're not another variable. So I'm going to go to Stat, Edit. Now I have information in there and I don't want it. So if I go up to L2, Clear, Enter. Go up, arrow up to L1, Clear, Enter. I can type in my values now. 5, 15, whoops, I forgot 15, 25, 35, 45, and 55. L2 is going to be my frequency list. 0, 4, 16, 64, 26, and 10. This is one variable statistics. We're only looking at the speed. So I'm going to go Stat, Calculate one variable statistics. My speeds are in L1. L2 is my counts, my frequency. Now I can get L2 by second 2 and calculate. And it's going to give me everything I need to answer the questions. Part I, so H1 says find the mean. So mean is X bar. So I would write X bar equals, you could write the entire calculator display, or 3 significant figures. And I would put kilometers per hour. They happen to not count it off on this test, but I would make sure I write it. And our standard deviation is the bar hat, I mean the circle with the hat, and that would be 8.85. And that actually isn't kilometers per hour, because that's really talking about how spread apart the data is. Last part. It is proposed that the speed limit past the hospital gate is reduced to 40 from the current 50. Find the percentage of these vehicles passing the hospital gate that do not exceed the current speed limit, but would exceed the new speed limit. So remember, we had 10 cars that were already exceeding it. We just need to look at the ones that are going between 40 and 50, because now there we get that ticket. So between 40 and 50 is 26 cars. So 26 cars out of a total of 120 cars. Let's see, 26 divided by 120 gives me 21.6, so 21.7 percent. I went ahead and changed it to percent in one step. You could do it in two, but it is 21.7%.